Example 12. Explain why the vector equation of a line has one parameter while the vector equation of planes have two parameters. I'll suggest look into my video on parameters so that you understand what parameters are. And there also we have answered it. Okay. Now, here is the short answer for the two. What is a line? So line is a single dimension thing, right? So it extends in one direction. The dimension of the line is kind of length, right? It moves in one direction. How about a plane? Plane is a two-dimensional thing, right? We'd normally represent it like a parallelogram, correct? So to define a plane, we really need two parameters which will take care of each dimension. And to define a line, we need one parameter which can take care of the dimension which is always changing, right? What is that parameter? If you see the vector equation, you can write the vector equation as, let's say, a point. Let's take general point ABC, right? Plus t times PQR, where PQR is the direction in which the line is moving and the parameter is t, where t belongs to set of real numbers. So it can take care of infinite number of points on a line. Do you see? So that's the parameter which will define our line, correct? So those variables which normally are x, y and z in R3, right? They can be defined in terms of the parameter t. Since the line is only one dimensional, we need one parameter. How about plane? For a plane, you know it is two dimensions. So we need to consider two parameters. And you also know that linear combination. Any vector on a plane can be represented as a linear combination of two vectors. So that helps us to represent any vector on the plane as combination of two. And those two are with two parameters, right? So a plane could be given as a point ABC plus one parameter, which is, let's say, one direction, like this, for example. And then another parameter, let's say PQR, right? So T and S, you can say these representing these two directions, correct? So in a plane, these two, length and width, you can say, right? That will identify each and every vector on a plane. And in the vector parametric form, in the vector equation of planes, T and S are the two parameters which are defining the plane, correct? So why do we need one or two parameters? It is because those many dimensions have to be taken care of. So here T and S should belongs to set of real numbers, and they can take care of infinite number of points. So these are the two parameters which take care of two-dimensional planes, and here we have one parameter to take care of one-dimensional line. Okay.